looking like you're ready to head out. Yes?
After this, can you also go over how to take the inverse sine to find the
Yes, we'll deal with that. Okay, so let's look at this case where we have two sides, B and C, and we have the included angle A, and we want to find the rest of the, we want to find the length of side A and the angles B and C. Now, the first thing that you always try, remember, is get the rest of your angles. And when you only have one angle, there's no direct way to do that. You know, if we had two angles, we can always easily calculate the third one just by adding them up and subtracting it from 180. But here we have to do something different. Now, since we have B and C, which are the sides that are the terminal and the initial side of angle A, the natural thing for us to use is the law of cosines. And so the law of cosines, you know, remember what I said on Monday, comes in three forms, and it really is just a question of what sides correspond to what. But the basic form of it is that if we're trying to find a side, you take the other two sides squared, and then you subtract that from 2 times those other two sides, times the cosine, and this really probably should say A in here. This is the angle that you know, the included side. And so we do this calculation, and the trap that a lot of people fall into is that they don't make this, they don't follow the order of operations. Don't calculate 5 squared plus 7 squared and subtract 2 times 5 times 7 from that and then multiply by the cosine. You're going to get the wrong answer. Take the 2 times 5 times 7 times the cosine of 40 as the term that you're going to subtract from the sum of those two squares. And so you get something like this. Always keep the full precision of your calculator going. And so learn how to use either the memory or probably more flexibly the parentheses on your calculator so you can do it all in one fell swoop and you don't have to re-enter numbers. And keep the precision up. And so we find that this a squared equals 20.4. And always remember that when you're using the law of cosines, it's easy to forget that this is a squared, not a. And so this number that you get is going to be the square of a. And so you just take the square root and you get 4.5. And so we're going to record that as 4.5. Okay. Now we're going to find out then what angle B is. Now here's the part that I want you to remember to do. When you're looking for what is another angle, if 40 was an acute or an obtuse angle greater than 90 degrees, it doesn't matter which one you choose next. But there's a possibility when you have one angle of 40 that one of the angles is going to be greater than 90 and the other one is going to be less than it, or both of them are going to be less. You won't have two angles that are greater than 90 degrees in a triangle, right? Because the triangle has to add up to 180, all the angles, and so you can't have 90 plus 90 because that's already 180 and there's nothing left over for the third one. So choose the side that's the shortest because that's the side that will guarantee that you get an angle that's less than 90. All right, when we look at, remember how the sine goes from quadrant 1 to quadrant 2, you can have the same sign for two different angles, one that's more than 90 and the other one that's less than 90. So in order to avoid that ambiguity of which angle is it obtuse or acute, just choose the smaller one and you're guaranteed to have the acute angle. And so then we get this value that's the sine of B equals 0.7 and other digits. So then, now the question is, how do you calculate that on your calculator? And I didn't bring a calculator today. I should have. May I, Chris? You have your TI-83 out. I assume most of you are using a calculator like this or something similar to it. And so. Now remember, I have to put this in a dark background to make it work. Okay, there the exposure is a little better. Cassandra has arrived. Nice announcement from the door, right? Okay, so if you notice, most of the calculators that you'll have, if you look at the trigonometric functions, sine and cosine, you'll see that they have the sine to the -1, or sometimes it says a sine, which is an abbreviation for arc sine, and that's just the inverse of the sine. So if I and make sure your calculator is set for degrees, and the easy way to check that is just take the sine of 90, and if you take the sine of, whoops, I'm working the calculator wrong, the sine of 90, and if you get a 1, can you see there's a 1 there? Just barely? Well, you can see that it's a 1. So you know you're at in degrees, and so if you take the inverse sine, there you'll see the inverse sine, and we can take a 1 there, and we should get a 90 back. Then you get a 90. Wow.
You can turn the brightness up.
It's the contrast that's killing us. Okay, so we get that. So it's basically just take the inverse sine. So you use the second function, this yellow key, second function, for the inverse sine, and then you just put in your angle. So you would expect, if you take the inverse of, wait a minute, 1/2, you would expect 30 degrees, right? And so that's all you do. And we're only going to use the inverse sine and the inverse cosine.
And for rounding, once you do that, then you can round to whatever you want.
Yeah, now WebWork asks you to round to like 4 digits or something like that. I think the appropriate rounding, considering the precision of the numbers that you're given, is really 1 decimal place. Okay, so work your numbers in with full precision. Okay, don't do any rounding until the very end, and then round the last answer. Now, it's very possible when you're doing these kinds of calculations that you get, like if you use the law of sines twice, you'll get an answer different than if you first use the law of sines and then calculate the remaining angle. Especially when you have angles that are close to 90, like the sine of 89 degrees is very, very close to the sine of 90. So you can get, some pretty significant calculation errors. So if you use the order that I'm suggesting that you use in finding these things, it'll minimize the amount of rounding errors that you get. Okay, so we find the inverse of the inverse sine of 0.7, and we get 45.4 degrees. Now from here, you can use the law of sines again to find out what C is, but why bother? That's too much calculation. Use the fact that you already have 40 and 45 degrees to find what that remaining angle is. So always, wherever you can, when you have 2 angles, use the sum of the angles equals 180 rather than keep on using these trigonometric functions, because there's less of a possibility of a rounding error. Okay, so then we know what C is. That's 180 minus 40 plus 45.4. And we get 94.6 degrees. All right, so if I look at this from the standpoint of going the other way around, let's say I used this 7 to figure out what the sine of C should be, and then use the inverse sine to calculate what C is. I get 2 numbers. This is the number that your calculator will display, or no, this is what the sine of C is this 0.9968. That's the sine of both 85.4 or 94.6 degrees. And so you're not sure, do you have the obtuse or the acute angle if you use the larger one? You're sure you have the acute angle if you use the smaller one. So it's a very, very important point to keep these calculations organized. Okay. All right, so here's some for you to try. I think you've already done the homework, so after we do this one, we can talk about the homework problem. So why don't you try that? Okay, so we're good with this one here. So now we have what's called the ambiguous case. And what the ambiguous case means is that we're going to have the angle that we know is going to be outside of B and A. Okay, so I want you to consider two things. What we had before was the angle side angle, where we knew a side, and then we know two angles. Now this is guaranteed to make a triangle, right? Guaranteed to make a triangle. If I tell you what this side is, and if I tell you what these angles are, you're guaranteed to get a triangle that works. So long as A and B are, add up to something less than 180. So long as they're pointing at each other, it will intersect here. Now with the law of cosines, what we had was we had two sides, and we had an angle. So it doesn't matter what the length of the two sides are. If you lay this out where you have an angle with two sides, here you're guaranteed to have a triangle as well, because all you have to do is connect these two sides. So in everything that we've worked with so far, we're certain that we're going to find a unique triangle. Now, there's a case here where if we know A and sides A and B are outside of that angle, there's three possibilities for these things. If A is longer than B, there's no problem. We get one particular triangle. However, if A is really short, of course, it's going to be, we're not going to get a solution here, right? If B is 100 feet long and A is a foot long, there's only certain values for A that will give us a triangle, right? I mean, think about this as like a crane and a hoist, that if A is a pretty good angle and A is much, much shorter than B, you're not going to have a solution. And then you have a case where you can have two solutions. If A is long enough, it's still shorter than B, long enough, but it's going to really be possible to make two different triangles out of this. And so you'll have two solutions with these. So if I go back to just kind of illustrating this, if we have, let's say, B here, and we have a certain angle, if A is longer than B, this is the only possible triangle, because if you swung it over to this side, we would actually have a triangle that looks like this, and then we wouldn't have angle A here anymore, we would have angle A over there. So A and B can form, a different triangle, but it wouldn't have the same angle A. Now, I think that second illustration, shows it. When A is much, much shorter than B, it's possible that it just doesn't make a triangle. This other one here, if you think about A being shorter than B, it can either be this triangle, or just imagine this thing as a hinge. I can swing this over, and this can be here. So I'll still have the same angle, the same side B, and A can be one of two places. And so this solution will come out because you're going to have the sine of an angle can be either greater than or less than 90 and still have the same value. So we'll take each case separate and learn how to identify them. So the first one is easy. If we have A is greater than B, or if we have the angle, now think in terms of generalities here. So I'm really only dealing with angle A, but if I know angle B, then I'm concerned that B is much larger than A for this case. Kind of work the mental gymnastics yourself. So here's a case where A is larger than B, and we will have a solution. We're guaranteed to have one solution. So how do we find this? All right, well, we use the law of sines for this, because here we have the ratio of the sine of 45 and side A, and so we can get side B that way, right? And so if I take my law of sines, where this is sine A over A equals sine B over B, and I multiply both sides by B, then I get this expression times 10. I'll have the sine of B, and then I just take the inverse sine of that, and I get 36.1 degrees. So I'm good with B. Now C is really easy then, because I use my angle addition then, just to take 45 plus the 36.1 and subtract that from 180, and I see that that's 98.9 degrees. And then once I have that, then I can use the law of sines again to calculate what C should be. And so here I have all my sides. So this one is two applications of the law of sines, one application of just the sum of the triangles. All right, everybody's up with the notes? Okay, so let's look at a case here where A is much, much shorter than B. And let's see what we get. And now, you have to decide, you want to be able to decide, is this going to be no solution or two solutions? Because once A is smaller than B, you're going to have one of those two cases. The only case that you'll have where there's exactly one solution is if the angle B turns out to be a 90-degree angle. Okay, and that does work that way sometimes. But anyway, so here we look at this ratio, and so we plug in what we know. That we know that the sine of A, which is the sine of 45, divided by 1, which is the length of A, and times the length of B is 10. So I get this value 7.071. And that's supposed to equal the sine of B. Now, if you're like me, you're just mindlessly calculating these things, and you try this on your calculator, and you get an error, okay? And the reason why you get an error is because the sine of B has to be less than or equal to 1. And since it's not, it's 7, that means that there's no solution. And so when you have the case, in the ambiguous case here, where you get to a value of a sine that is larger than 1, that means it's an impossible triangle. So there's no solution. That's the case where A is just far too short for what we're trying to do. Okay, so let's look at the double case now. So here's a case where we have A is smaller than B, and so I'm going to see what angle B should be. And I'm going to use the law of sines for this. So the sine of B equals B times sine of A over A, and I get 0.88388. Okay, very good. I got a solution to this thing, or I got at least a measure of what B could be. It can be one of two values. If we take the sine of 117.9, we'll find that it equals the sine of 62.1. Think about this on your unit circle, where this angle is. So if we have an angle that's, in this case, 62.1, which would be something like this, and here's the sine right here, then if I start at 180 and go back 62.1 degrees, I get this angle here, which is 117.9, and this, of course, then is the sine of 117.9. So the way you calculate that second angle is that you take 180 minus the first angle. So in other words, we're starting here and we're backing up to it, and here we're just going out to 62. So we find this angle, which will give us the same sine, by starting at 180 and making this angle equal this angle. And so that's how you calculate it. 180 minus 62 will give us 118. All right, so we have two sides now. So we have two possible solutions. And so that means we have two possible solutions for angle C as well. Okay, so we have 72.9, or we take 180 degrees minus the other two angles, and we get two possibilities here. Okay, so the only thing we're missing is side C now. And so side C, we get by using the law of sines again, and we just remembered that we use the corresponding sides, or the corresponding angles, that either 72.9 or 100, that should say 117.1. Or no, excuse me, it is 17.1, because that's what C, the alternative for C is. And so it's either 10.8 or 3.3. Okay, so let me see if I can make a sketch of this, just to show you what's going on with this. So we have angle A, which is 45 degrees, so I'll try and make this a 45-degree angle like this. And then we figured that B, well, B is 10, okay, and C is either 10.8, so it's either this, or it's going to be, let me see, is that about right? Make it a little further out, like this. Or it'll be 3.3, which is like this. And so side A is 8, so side A is either this side or this side. Okay, so this is side A, those are 8. And so this angle here, which is angle C, excuse me, angle B. This is angle B, right? So angle B is either 117.9 degrees, or angle B is 62.1. And this is angle C, so this is either 10 degrees, or excuse me, 72.9 degrees, or this smaller angle here is going to be 17.1. So this is in a little bit more scale than my sketch. And it's not necessary to draw this unless you really are trying to design something mechanical or really want a good feel. But you see how you can get two different triangles. This angle here was 45. Okay? All right, so now it's time to try a few of these. And I won't tell you which ones are what. All right, so I'm going to write these on the board, and I'm going to probably write two at a time, one on each side of the board, and I'll ask you to come up and solve these. Okay, so you'll have to decide what path to take. And Noelle, will you do the first one on the board? Work on it at your place, ask help for some friends, and when you're done, then come up. And Ranjay, why don't you do this one, okay? So work it out in your books when you're done.